Hello and welcome to YellowMan Physics. Today I'm going to go through radioactive decay and the types of radiation that we get. Okay, so the first point is that unstable nucleus give out radiation to become more stable. So remember your classic model of protons, neutrons in the center. You've got your electrons whizzing around the outside. Stick another one, right? This is a bad example essentially because normally our radioactive nuclei have a lot more protons, a lot more neutrons, but I haven't got time to draw them all. But we are talking only about the nuclei. In all of this radiation stuff, we completely forget about the outside and we are only concerned. So you don't talk about atoms, you talk about the nuclei. We're concerned about the center of the atom. So we talk about the nuclei. This nuclei here is unstable, and to calm itself down, to become more stable, it's going to give out some form of radiation. Okay, and that form of radiation can take one of four types, but we tend to focus on three. So the first is alpha, the second is beta, the third is gamma, and the last one, which is a new addition to the spec, are neutrons. So alpha, which is a helium nucleus consisting of 2 protons, 2 neutrons, badly drawn like that. Beta is a high-speed electron. Gamma is just an electromagnetic wave, and a neutron, well, is a neutron. Okay, now the symbols for these: alpha is like this, beta is like a B with a big bum, gamma I draw like that, and neutron is just an N. So if we look at these things here, we just need to put some properties off of these. So this is a helium nucleus. It has a charge of 2+ because there are 2 protons but no electrons to cancel it out. So a charge of 2+, or 2+. This is a high-speed electron, the beta particle. It has a charge of -1. This one, gamma, is an electromagnetic wave. And it has no charge. 0. And the last one, well, the neutron is a neutron, and neutrons are neutral. It has no charge. Now let's get rid of this bit over here. Now the other piece of information we're missing from this is their penetrating power. Now the helium nucleus is the biggest. It's got a mass of 4 because it's made of 4 things from the nucleus. This is a big beast of radiation. It also has a charge of +2, which means it's very ionizing. It wants to grab 2 electrons off of stuff that it comes into contact with. So it's big and it's very ionizing, and that means it doesn't go very far before it bumps into something. So the classic picture, which I'll try and draw here, this is going to be a piece of paper, and an alpha particle, I'll just use the symbol, is stopped by paper. Next one in terms of penetration ability is the high-speed electron. Now that is stopped by aluminium, a sheet of aluminium. So it will go through the paper, but the beta will be stopped by aluminium. And then the last one, thick lead or concrete. Let's just say lead because I probably can't fit the word concrete on the end here, will be for the gamma. Goes through the paper, through the aluminium, and some of it is going to go through the lead, but some of it will be stopped by it. Okay, so gamma is the most penetrating, beta is the next most penetrating, and alpha is the least. Now this links into how ionizing they are. So the ionizing comes back to their charge, and we can see that we go +2, -1, and 0. Now we need to talk about this little electron, this little neutron at the bottom, sorry. Neutron radiation is a new addition to the spec, and they don't actually want you to know about it in terms of its penetrating ability in this classic picture that you'll see in the revision guides. All they want you to know about the neutrons is that it can be given out by an unstable nuclei. Okay. For interest, neutrons can travel very far in air, but they tend to be stopped by things that are hydrogen rich, like water and things like that. So, let's remove the neutron off the bottom of here, make some space, and strike that. I'm going to get rid of all of this as well, and let's just make a little mini table here and go alpha. Alpha has a mass of 2, has a charge of, meant to say 4 there, has a charge of +2, ionizing, so let's just say it's strongly ionizing. They like the use of comparative words. Stopped by alpha, centimetre of air or a sheet of paper. So sometimes it's a few centimetres of air, approximately a few centimetres, alright. Beta has a mass of virtually nothing, because it's an electron. If you want to help with your chemistry revision, 1/1840, something like that. Virtually nothing. Charge of -1. Ionizing, it's less ionizing than an alpha particle. Beta is less ionizing, but it's more ionizing than gamma. Sometimes we could say moderately ionizing, but often in an exam question you're going to compare it to either alpha or gamma. So it's somewhere in the middle. Stopped by aluminium foil, approximately 3 ml, but let's not worry about that. And then the last one, gamma, mass of nothing, because it's an electromagnetic wave, charge of nothing. It is weakly ionizing, and it's stopped by centimetres of lead, so a few centimetres of lead, or meters of concrete. Concrete, which I can't spell, obviously. Let's go with that. Just going to get rid of this bit here because I'm thinking just want to compare their distance in air. So this one, alpha can go a few centimetres, beta can approximately in air, so let's just add a column in here for air, how far they travel in air. So this one is a few centimetres for alpha. Beta can go approximately about 1 metre, and gamma can go for many kilometres. Okay. Now the reason that the charge and what they're made out of is important is because it affects what they're stopped by. So it's got this alpha has a charge of +2, which means it's strongly ionizing, which means it really wants to interact with whatever it hits, so it's stopped very quickly. Beta is charge of -1, moderately ionizing because it does have a little bit of a charge, but because it's so small it also has a less chance of colliding with anything and causing ionization, so it takes something a bit thicker, a bit more material to stop it. And then gamma, which has no mass and no charge, the chance of that interacting with something is even less, so it will go for a really long distance before it's stopped by anything or interacts with anything.